Welcome back everyone. Today we're going to continue our series on BL Heli 32 settings. Today we're going to tackle input frequency. I guess most drone people will be running D-Shot, which is a much higher frequency than this, but we're using, well, in this example we're using the servo library, which you can adjust the frequency. So default is 50 and the max is 500. So I wanted to see if that made an actual difference to the delay of the controller / spin up time, and it did make quite a large difference, quite a huge difference. So this is 500 here and this is 50 here, and it delays the signal, if you like, 500 versus 50 by 33 milliseconds. So if you run it at 50 Hertz, you'll get delayed by 33 milliseconds over 500, which means we should all be using 500. There is also a greater variance which can be seen between here and here and here and here. This is 9 milliseconds of variance here, and this is 22 milliseconds. The other thing to point out, I have left these black lines in here. They are to deal with the next question of how come it appears to be starting here and not at 0. They actually do, well, I don't know about the 50 Hertz, but the 500 Hertz does actually start at 0. At this point, which is actually 4 milliseconds, it's doing 128 RPM. So obviously it can't go from nothing to 128 RPM, so it did start before, and just the way the dyno works by having a round disc with some holes in it, obviously you need some kind of rotation to be picked up. So the first rotation is effectively its second rotation, which is not, well, we're not talking about an entire rotation. But anyway, the point is that it does pick it up before. Now, how come there's these funny horizontal lines? I believe that is actually BL Heli doing the computation, where it seems to send us power to it to get computation, which doesn't really spin the motor but does move it. Well, it does that while it gets into a known position, and then it spins it after that. So there's actually quite a lot of plots that have this kind of horizontal lump in them, but I have removed them for this this dyno plot because it makes it look a bit messy and hard to understand. But I've left those two in to see that it actually does start prior to that, effectively 0. 4 milliseconds from the dyno point of view is as fast as it can pick it up. That's effectively 0 point. Yeah, so that is the short discussion on input frequency. We should definitely be running 500 Hertz because it definitely makes a difference. It reduces it by 33 milliseconds and reduces the inconsistency. So I will see you on the next one. Alright guys, bye bye.